Good evening, everyone. Am I audible? Good evening. Am I audible? Okay. Good evening, everyone. Welcome to GoScore Learning, the fastest growing edtech in GCC, and our main aim is to provide quality education for all. I am Tanya Ragesh, teacher from the Department of Chemistry, GoScore Learning. Today I am here to discuss the sample question paper 2023-24. We are discussing the chemistry sessions today. Okay, are you all ready? Can we move on to the first question? Okay, so the first question is, they have given you an image in that we have a test tube containing barium chloride solution and we are adding a test tube containing a solution of sodium sulfate. Okay, so your question is, so we can just write here the equation. We are taking the barium chloride, that is BaCl2, and we are adding sodium sulfate, that is Na2SO4. Okay, so identify the product which represent the solid state in the above reaction. Okay, so we know that when barium chloride react with sodium sulfate, what type of reaction is this? What will be the product? It will be a double displacement reaction, right? That is a precipitation reaction. So a precipitate is forming there, right? So double displacement means you will be getting what your product is, barium sulfate, which will be precipitated. Sorry. Barium sulfate plus 2 molecules of sodium chloride will be forming there, right? So here the precipitate formed as barium sulfate and the type of reaction is double displacement or precipitation reaction. So what is the product formed here? Yes, of course it is barium sulfate. You have option barium chloride, barium sulfate, sodium chloride and sodium sulfate, and the correct option is nothing but barium sulfate. Your precipitate formed as barium sulfate. Okay, done. So your first answer is option B, barium sulfate. Now we are moving on to the second question. Okay, your second question is the color of solution observed after 30 minutes of placing zinc metal to copper sulfate solution. So you are placing zinc metal to copper sulfate solution. So in the reactivity series, we know that zinc is more reactive than copper, right? So definitely zinc will displace copper from its salt solution. And the type of reaction is nothing but displacement reaction, right? So here as zinc is more reactive than copper, zinc will displace copper from its salt solution and you will get ZnSO4 plus copper, right? So what is the color of copper sulfate solution? Yes, copper sulfate is blue color solution, and after displacement the compound formed as zinc sulfate, which is a colorless solution. So right, so what is the color of solution obtained after 30 minutes of placing zinc metal in copper sulfate solution? It is nothing but zinc sulfate, and which is a colorless solution. So your correct option is option B, colorless. Okay, now we are moving on to the third question. Which one, given the among the given options, which one is a mild non-corrosive basic salt? And you know that clearly the mild non-corrosive basic salt among the given option is nothing but sodium hydrogen carbonate or sodium bicarbonate. that is commonly known as, what is the common name of sodium hydrogen carbonate? Is exactly, it is baking soda. Sodium hydrogen carbonate, which is commonly known as baking soda, and its chemical name is sodium hydrogen carbonate, or you can write it as sodium bicarbonate, right? And do you remember the method of preparation of baking soda? Is what are the reagents that we will use to prepare baking soda? It is NaCl plus H2O. What is this NaCl plus H2O known as? It is called brine, right? Brine. Okay. And what is the next reagent? Sorry. Carbon dioxide plus NH3, ammonia. You will be getting what? NaHCO3 plus byproduct is NH4Cl, ammonium chloride. This is what the method of preparation. I just told you for just recollecting or remembering these things. Okay. So here in this question, the mild non-corrosive basic salt is nothing but sodium hydrogen carbonate or the baking soda. Okay. So your next question, on adding dilute sulfuric acid to a test tube containing a metal X, a colorless gas is produced, and when a burning matchstick is brought near it, which of the following correctly represent a metal X? So you have a metal X, and when you add dilute sulfuric acid, when you are adding dilute sulfuric acid to that metal, that is, here the reaction is metal plus acid. What happens when a metal react with an acid? Do you remember what happens when metal react with acid? Yes, you will get salt plus, which is the gas evolved. The gas evolved is nothing but hydrogen gas, right? And what happens when a metal react with, when a metal carbonate, or metal hydrogen carbonate react with acid, what you will get? Is you are getting salt plus water plus which gas will be evolved? The gas evolved is nothing but carbon dioxide gas, right? So here you are taking a metal X and you are adding dilute sulfuric acid into it. A colorless gas evolved produces when a burning matchstick is brought near it. So here the gas produced is nothing but hydrogen gas. Okay. So which of the following correctly represent metal X? So in order to produce the hydrogen gas, the metal should be above hydrogen in the reactivity series, right? So among the given option, we know clearly that the silver metal and copper metal, which comes below the hydrogen in the reactivity series, right? So in the reactivity series, after hydrogen, the copper, gold, silver, platinum, these all metals are coming, right? So these all are less reactive than hydrogen, so it cannot displace hydrogen from the, it cannot liberate hydrogen gas in the acid medium, right? So definitely this copper and silver will not be there, and sulfur, it is a non-metal, right? So sulfur may not be the option. So your correct option is the metal sodium, which is on the top of the reactivity series and is a highly reactive metal, right? So the correct option is, here it is, the metal can be sodium metal. Okay, so I hope it is clear for you. We are moving on to the next question. Which one of the following correctly represent sodium oxide? So what is sodium oxide? It is Na2O, right? The valency, we know that the valency of sodium is 1 and that of oxygen is -2, right? So when you cross, right, it will be Na2O. Okay. So now I want to represent the electron dot structure of sodium oxide. Let's see how we can write the electron dot structure. So for sodium, the electronic configuration is 281, right? And for oxygen, the electronic configuration is 2, 6, right? So for sodium, we have 1 valence electron, and for oxygen, we have 1, 2, 3, 4, 5, 6 valence electrons, right? So we have 2 sodium, Na2, 2 sodium. Each one will be giving out its 1 valence electron to oxygen, and sodium will form Na+1 by losing only 1 electron. Sodium has only 1 electron in its valence shell and it can donate only 1 electron. Like that, we have 2 sodium. Each sodium is giving out its 1 valence electron and it will form Na plus ion. Like how many Na plus ions we have? We have 2 Na plus ions, right? So, it will be forming 2 Na plus. If you are writing Na2 plus, is it correct? It is entirely wrong because this indicates that sodium is losing 2 electron. Is sodium have 2 valence electron in its outermost shell? No, right? So sodium, if you are writing Na2 plus ion, it is wrong. It is not the electron dot structure. So for electron, when you are writing the configuration, it will be 2 Na plus. We have 2 sodium elements which each one losing 1 valence electron to form Na plus ions. And as oxygen is gaining 2 electron, it will form what? It will form 1, 2, 3, 4, 5, 6. It is gaining 1 electron from 1 sodium and then another 1 electron from the next sodium. And here the oxygen atom is gaining 2 electron and it will form 2 minus. Okay. So this is the correct representation of sodium oxide, and now we can check for the options. Here it is Na2 plus is given, so that is entirely wrong. Here also 2 Na plus and oxygen 2 minus, that is okay. Here it is 2 Na plus and 2 O minus 1. That is wrong because oxygen is gaining 2 electrons, right? So this is not okay. Na plus and oxygen, we have 2 sodium. Here only 1 sodium is given. So this option is also wrong. So your correct option is option B, that is 2 Na plus oxygen 2 minus, which represent the sodium oxide. Okay. So I hope it is clear. This electron dot structure and the configuration is very important. So please go through that. If you have any doubts in that, please give in the comment box. We will give the detailed explanation about it. Okay. So can we move on to the next question? So your next question is, an element with atomic number dash will form a basic oxide. So we know that what metals when combines with oxygen, it form metal oxides, right? The metals form metal oxides. Okay. So just a moment. Metals form metal oxides, right? And what's the nature of this metal oxides? The metal oxides are, yes, the metal oxides are basic oxides, right? And usually the non-metal form non-metal oxides, and these non-metal oxides are acidic oxides, right? So here they have asked you which element will form the basic oxide. So what you want to find out, whether which one among the given option is a metal. Now see, we have option A, that is 7. It will have the tendency to gain electrons. So it will be a non-metal, right? Here the option B is 17, that have electronic configuration 287, that also have the tendency to gain the electrons, right? So that is also a non-metal. And here we have 14, that is 284. It will be having the tendency usually to form the covalent bonds, right? And that option D is option atomic number 11 with electronic configuration 281. So that means the option D is a metal, right? So your correct option is option D with electronic configuration 281, which have the tendency to lose the electron, and as it is a metal, it will form the metal oxides, which are basic oxides. Okay, that's it. Now we have the next question, that is, an element M has 50% of electrons filled in the third shell as in the second shell. The atomic number of M. Okay, so you want to find out the atomic number of M. Okay, and they have given you that, we know that what are the shells? It is K, L, M, right? So in that the K shell can accommodate a maximum of 2 electrons, right? What about L shell? L shell can accommodate a maximum of 8 electrons, right? So here in the question it is given M has 50% of electrons filled in the third shell, and M has 50% of electron filled in the third shell, that is in the M shell, as in the second shell. So this M has 50% of electrons as in the second shell. That means M has how many electrons? 4 electrons, right? That is the 50% of the second shell. If second shell has 8 electrons in it, its 50% in the third shell means it is half. That is the 4 electrons, right? So together how many electrons? 2 plus 8 plus 4. We have 14 electrons in the element, in the element M. So the atomic number of M is nothing but 14, right? So I hope it is clear for you. So now we are moving on to that are the MCQ questions from chemistry part, and now your assertion reason question. So in the assertion reason question, the assertion is rusting of iron is endothermic in nature, and as the reason is, as the reaction is slow, the release of heat is barely evident. Is rusting of iron is an endothermic reaction. It is, what do you mean by endothermic? The reaction which utilizes energy, right? So is the corrosion or the rusting of iron, is it an endothermic? No, right? It's an exothermic reaction. So this rusting of iron is an endothermic reaction in nature is a false statement, and the reaction is slow, that's why the release of heat is barely evident. Okay, so the statement given, recent statement is correct one, but the rusting of iron is an exothermic reaction. So your correct option is assertion is false, but reason is true. Okay, these are the questions covered in this section A. Now we are moving on to the section B that carries 2 marks. Okay. So for a 2 mark question, that is, you are adding dilute HCl So you are adding zinc granules to dilute HCl. Okay. So you want to prove that a chemical change has taken place here, and support your response with 2 arguments. How will you know? What are the characteristics? You have learned the characteristics of reaction. What happens when a chemical reaction is happening, right? So in that you have learned the change in the temperature, the color change, evolution of gas, formation of precipitate. Like that, few characteristics you have learned, right? So here when you add zinc granules to dilute HCl, what will happen? It's a metal reacting with an acid, right? So there will be formation of salt, that is zinc chloride, plus which gas will be evolved? Hydrogen gas will be evolved, right? So how can you prove that a chemical change has taken place? Here with the evolution of gas, right? With the evolution of gas, we can say that there a chemical reaction happened, right? And or you can write as here there will be a slight color change when you add zinc granules to dilute HCl. A slight color change will be there, which also indicate that a chemical reaction happened there. And the next thing is that when you touch the beaker that carrying out the reaction, it will be little bit hot. That means heat is giving out, or the temperature change will be there. That also indicate that there a chemical reaction happened. Okay. So with these three statements, you can confirm when you add the zinc granules to the dilute HCl, then a chemical reaction is happening. Okay. So that is the question from the section B for 2 marks. Now we are moving on to section C, which contain 3 marks questions. Okay. So your section C question is, the given reaction shows one of the process to extract the metal like iron and manganese. So you know clearly that for the extraction of manganese and iron, we are using the process that is, I told you in the previous live session that the thermite reaction, which is very important, and you should know the balanced reaction for thermite reaction as well, right? And which are the metals which we are extracting using the thermite process? It is nothing but iron and manganese. Okay? And why it is called a thermite reaction? Because during the extraction process, a large quantity of heat is liberated, right? And the extracted metal is usually in the form of the molten state, right? That's why we are using this iron extracted by thermite process for joining the cracked railway tracks or the cracked machine parts, etc. Right? So here, so you have recollected all those things. Now we can move on to the question. So the given reaction is MnO2 plus aluminium gives manganese plus aluminium oxide, and heat is liberated. And here you can see the extracted manganese is in the liquid state, right? Give reason why the above reaction is known as thermite reaction. Why the given reaction is known as thermite reaction? As I mentioned, in this, during the reaction, a large amount of heat is liberated, right? A large amount of heat is liberated and the extracted metal is in its molten state. That's why this reaction is known as thermite reaction. So your answer for section A is because of the large amount of heat liberated. As a result, what happens? The extracted metal manganese will be in the form of molten state or in the liquid state. That's what we are representing here with the L. Okay. So now second question is, identify the substance oxidized and reduced in the reaction. I am just rewriting the reaction here. MnO2 plus Al gives manganese plus Al2O3. Now see, which one is getting oxidized here? For here aluminium, oxygen is being added up, addition of oxygen, that is oxidation. So we can say aluminium get oxidized. Aluminium get oxidized to aluminium oxide. And for manganese dioxide, what happens? MnO2 get loss of oxygen, removal of oxygen. So what is that? Addition of hydrogen or removal of oxygen is reduction process, right? So here MnO2 is reduced to manganese. So you can say this is an example for redox reaction, right? Because both oxidation and reduction is occurring. So this is a type of redox reaction or an example for redox reaction, right? So in this one, which substance is getting oxidized? We can say clearly that aluminium is getting oxidized to aluminium oxide, and which one is getting reduced? MnO2 is reduced to manganese, right? So Ming this, which one is the oxidizing agent and which one is the reducing agent? That question is not there. I am just asking which one is the oxidizing agent and which one is the reducing agent. Here, as aluminium is getting oxidized, aluminium will act as the reducing agent, right? So as aluminium getting oxidized, the reducing agent is aluminium. And which one is the oxidizing agent? As MnO2 is getting reduced to manganese, MnO2 will act as the oxidizing agent, right? So for B question, the substance get oxidized is aluminium and the substance get reduced is nothing but MnO2. Okay, next one is third question. That is for 3 mark question. If you wrote it for this answer, you will get 1 mark. This one 1 mark. This one 1 mark. And your last 1 mark question is give a reason why aluminium is preferably used in thermite reaction. Why we are using aluminium in thermite reactions? What may be the reason? The first reason is aluminium is highly reactive metal, right? Aluminium is highly reactive. That is the one reason we are using aluminium here in the thermite process. And we know that aluminium is more reactive than iron and manganese in the reactivity series. And due to that high reactivity, we are using aluminium. And aluminium also have more affinity for oxygen. But the main reason is aluminium is more reactive. So in your answer, aluminium is more reactive metal, and in the reactivity series, this iron and manganese, which we are extracting by the thermite process, comes below hydrogen. So that is the reason we are using aluminium in the thermite process. Okay. So I hope it is clear. We are moving on to the next question. There is one more 3 mark question in section C. That is, okay, it's an OR question. Okay, we can discuss the first one. Let me check. So we can discuss the first one. An element M with electronic configuration 2, 8, 3 combines separately with the chlorine and sulfate ion. Okay. Write the chemical formula of the compound formed. Predict with a suitable reason the nature of the bond formed by element M in general, and how will the electrical conductivity of the compound formed vary with respect to M. Okay. So for this question, if you are writing the chemical formula for the compound when it combines with chlorine and sulfate ion, for chlorine ion we will be getting half mark. For sulfate ion, you will be getting the another half mark. So it's a 1 mark question. And predict the suitable reason, the nature of the bond formed. That if you are explaining the type of bond formed along with the given reason, then it will be getting 1 mark. And about the electrical conductivity, if you are explaining, you will be getting the another 1 mark. Okay. So in your answer, each one should be specifically mentioned and you have to underline the main important points. Okay. Or you have to highlight that answers. Okay, now let's see what are the answers. So you have the metal M with electronic configuration 2, 8, 3. So it has a valence electron 3, right? 3 valence electrons are there and it have the tendency to lose this 3 valence electrons. So it will be having the valency plus 3. So your metal M is having the valency plus 3. Now we want to find out the chemical formula of the compound formed when the metal M combines with chlorine ion and a sulfate ion. So it's very easy, right? M have valency plus 3 and chlorine have valency 1, right? When you cross it, you will be getting the formula NCl3. This is the formula of the compound, chemical formula of the compound when the metal combines with a chlorine ion. Okay, chloride ion. And when M with valency 3, that is plus 3. This is plus 3 and chlorine is, minus 3. When combines with the sulfate ion, which have valency minus 2, right? So when you cross it, it will be M2. As it is a polyatomic ion, you have to put it in the bracket. M2 SO4 3 minus. So this is the chemical formula of the compound formed when the metal M combines with a sulfate ion. Okay. That's it. So if you wrote it both this one neatly, you will get the 1 mark for that. And the next question is, with a suitable reason, the nature of bond formed by element M in general. We know that M has the tendency to lose the 3 valence electron, right? So it will form a cation M3 plus ion by losing the 3 electrons. So it have the tendency to combine with an anion, and the ion produce, the type of bond formed between the metal and the combining element will always be what? Ionic bond. That is the bond between the oppositely charged ion, that is the cation and the anion. That we know clearly that the opposite charges attract each other, and the cation and anion will attract each other, and the cation is formed by losing the electron and anion is formed by gaining of electron. And as here the metal M have the tendency to lose the electron, the nature of the bond formed by element M in general will be ionic bond, right? And what about the electrical conductivity of the compound? We know clearly that the ionic compounds in their solid state will not conduct electricity, but in their molten state and in the aqueous solution, it can conduct electricity, right? Because in the solid state, in the ionic compound, the cation and anion is tightly held together, right? When it is in the molten state, what happens? As you are melting it, the bond breaks and we will be having separate positive charged ion and negative charged ion, that is free ions are present which can conduct electricity. Same like in the aqueous solution also. When you are dissolving it in the aqueous solution, ions will be produced, and due to the presence of the free ions, the aqueous solution can conduct electricity, right? So you can write here that as the compound of metal M, in their solid state, it cannot conduct electricity, but in the molten state or in the aqueous solution, as it is an ionic compound, it can conduct electricity, right? Okay, that is the first question. And if you are moving for the OR question, we can see the OR question also. A reddish brown metal X, okay? So which one is the reddish brown metal X? That is, it may be copper, and when you are heating it in air, it gives a black compound. Why? You have learned that copper, reaction of copper with oxygen, you are getting a black color, copper oxide in the first chapter, right? So maybe it is the question, I think it will be that one only. So a reddish brown metal X when heated in air gives a black compound Y, which when heated in the presence of hydrogen gas gives X back, that you are reducing the copper oxide, you are getting copper back, right? X is refined by the process of electrolysis, that it will be coming on the bottom of the reactivity series, and it is used in the electrical wiring. So we can confirm that X is copper, right? Identify X and Y and draw a labeled diagram to represent the process of refining of X. To remember the process of refining of X, there is a diagram given in the reader, that is the impure copper, we will kept it as anode, and the pure copper, we will kept it as cathode, and the salt solution containing copper, that usually copper sulfate is taken as the electrolyte, right? So here for identifying X and Y, you will be getting 1 mark, and for drawing the neat labeled diagram, 2 marks will be there. So when you are drawing the diagram, Please make sure that you have drawn it very neatly and labeled each and every part very neat way. Okay? You use pencil for drawing the diagrams and mark each important parts. Label them properly. For drawing, their neatness is very important, and try to draw the diagram very neatly. Okay? So now see how we can identify. Here I have given the diagram. It's there in your reader. We are taking the impure copper as anode and the pure copper as cathode. And you are taking the copper sulfate, the salt solution of the same metal, as the electrolyte. And we are connecting it to the battery. And as the process carried out, what happens? The impurities coming from the anode will settle down at the bottom of the beaker, which is called anode mud. That is the impurities, right? Okay, you have to mention impure copper, which we are connecting as to the anode, pure copper to the cathode, and have to take the copper sulfate solution. Okay, so here X, as it is a reddish brown color metal, we can say X can be copper. Okay, and when you are heating copper, that is you are heating copper, what you are getting? Copper oxide, right? And now this is X, and you are heating in air, gives a black compound Y. This is your Y, and this Y, when you pass excess of hydrogen gas, what you will get? You are getting copper plus H2O, right? You are getting copper plus H2O. That means you are getting X back when you treat Y with the hydrogen gas, when you carry out the reduction of Y, right? So your X is copper and your Y is copper oxide, copper 2 oxide, right? So I hope it is clear. This is the 3-mark question and the mark distribution for that one. Okay. So when you are writing the answers, please keep in mind how the marks will be distributed and write the answers according to the mark. Don't simply write X can be copper. Give reason why you are predicting or why you are telling that X is copper. Okay. Just a moment. Okay, now we can move on to the 5-mark question. Okay. So this is the 5-mark question. We have options, our question is there. So we can discuss one by one in detail. We will be discussing the both questions. Okay. So first we can go for the first question, that is Thermite classified. I will take in this a separate slide. So Thermite classified the reaction between methane and chlorine in presence of sunlight as a substitution reaction. Support Thermite's view with a suitable justification and illustrate the reaction with the help of a balanced chemical reaction. So here Thermite has mentioned that the reaction between methane and chlorine in presence of light. So we know that usually the saturated hydrocarbons undergo what type of reaction? The saturated hydrocarbons undergo substitution reaction, right? And what about unsaturated hydrocarbons? Unsaturated hydrocarbons usually undergo addition reactions, right? So we know that, just keep in mind, saturated hydrocarbons always undergo substitution reaction, and unsaturated hydrocarbons always undergo addition reaction, and both the saturated and unsaturated compounds will undergo combustion reaction. Okay. So here this is a saturated hydrocarbon. So definitely it will undergo substitution. And what do you mean by the substitution reaction? Substitution reaction is nothing but the one element is being substituted by another element, right? So in the methane, we know that methane has 4 hydrogen, right? So if any of this hydrogen atom is being displaced or substituted by another element. So when you are treating with chlorine, what happens is this hydrogen will be substituted by chlorine, and this evolved hydrogen will react. We have 2 molecules of chlorine there, right? So one chlorine will come and substitute the hydrogen, and the released hydrogen will combine with the remaining 1 chlorine, and what will be the product you are getting? You will be getting CH3. Among the 4 hydrogen, 1 hydrogen replaced by chlorine or substituted by chlorine. So you will get CH3Cl plus, and that replaced or substituted hydrogen combined with the remaining chlorine atom to form HCl as the byproduct. And what is the name of the product? Here we are taking this one as methane combining with chlorine gas in presence of sunlight. What is the product formed here? CH3Cl, right? So you are getting, what is it? Chloromethane plus HCl as the byproduct. And if you are passing excess of chlorine gas, what happens? CH3Cl. Again, if you are passing chlorine in presence of light, you will be getting one more hydrogen from the CH3Cl. Chloromethane is substituted with the chlorine, that you will get CH2Cl2 plus HCl. And I can write the name of the product. Here it is chloromethane. In treating with chlorine gas, what is the CH2Cl2? We have 2 chlorine, right? So it is 2 chlorine, that is di. Di means 2, right? Dichloromethane. You will be getting dichloromethane. And this dichloromethane, that is CH2Cl2. Upon treating with chlorine by passing excess of chlorine in presence of light, what you will get? One more hydrogen being substituted or replaced by chlorine, that your product is, so CH2, one more hydrogen displaced means or replaced means you will be getting CHCl3 plus HCl, right? So what is this? This one is dichloromethane. On treating with chlorine gas, what is the CHCl3? We have 3 chlorine, right? 3 chlorine means it is tri chlorine, right? So it is trichloromethane. And do you know what is the common name of this trichloromethane? It is commonly known as chloroform. Okay. And lastly, when you treat the CHCl3, you are passing chlorine gas in presence of light. We have one more hydrogen, right? That also replaced by chlorine, and you will get CCl4 plus HCl. Okay. So what is this? This is trichloromethane. And what is the CCl4? It is, we have 4 chlorine, right? So it is 4 means tetra. It is called tetra chloromethane, or also known as carbon tetrachloride. Okay, tetrachloromethane. This is what the substitution reaction of methane when presence of treating with the chlorine in presence of light. Okay. So when you treat methane with chlorine gas in presence of light, you will get chloromethane and HCl. If you are passing excess of chlorine, this chloromethane again react with chlorine to form dichloromethane and HCl, and this dichloromethane on reacting with excess of chlorine, it will form trichloromethane, which when treated by passing excess chlorine gas, you will be getting tetrachloromethane. Okay. So that question is clear, right? Now we can move on to the second part of the 5-mark question, that is chlorine gas was prepared using electrolysis of brine solution. Write the chemical equation to represent the change and identify the other product formed in the process and give one application of each. So you have to write the, this is the passing of chlorine gas through brine solution, that is what known as chloralkali process, right? Why it is called chloralkali process? Because after the electrolysis of brine solution, we are getting an alkali along with chlorine gas, right? That is why the reaction is known as chloralkali process. So for this question, you have to write the chemical equation for chloralkali process and what are the other product formed, and you have to mention the application of each one. Okay. So this will be carrying 3 marks, and for this it will be 2 marks. Okay, that's together 5-mark question. So what is chloralkali process? What is brine actually? Yes, we have discussed, right? Brine is sodium chloride in water. That is called a brine. Right? When you are passing electricity, through the brine water, you will be getting sodium hydroxide, which is a water soluble base, and the water soluble bases are called alkali. So you are getting an alkali plus chlorine gas plus hydrogen gas will be formed, right? So as in this reaction, you are getting an alkali and chlorine gas. That's why this reaction is known as chloralkali process. And when you balance the reaction, here we have only one chlorine, here 2 chlorine is there, so put a coefficient 2 here. And now we have 2 sodium, here only 1 sodium, now put a 2 here. And now check how many hydrogen on the right hand side. We have 2 2s are 4 nitrogen. On the left side we have only 2 hydrogen. So put a coefficient 2 here. Now we have 4 hydrogen, 2 oxygen on the right side, right? So 2 sodium, 2 chlorine, 4 hydrogen, 2 oxygen. Now it is a balanced reaction, right? So we have written in the question, I think it is to write the chemical equation to represent the change. So we have written the balanced reaction. And what are the product formed here? We have sodium hydroxide, we have chlorine gas, and we have hydrogen gas, right? So in this one, at the anode, when you are passing electricity, at anode, which gas will be collected? Anode is positive charge, right? So definitely the negative charge ion, that is Cl minus ion, will be coming to the anode, where it will be losing electron. That means it will be undergoing oxidation to convert to chlorine gas. So at anode, chlorine gas will be liberated, and at the cathode, what happens? H plus ion will be passing to the cathode, and it will be getting reduced to form hydrogen gas, right? So actually what happens here? What is happening here when you pass electricity to sodium chloride and water solution? What happens? The sodium chloride will break up to form Na plus and Cl minus, and H2O will produce H plus and OH minus ion. Right? In this one, the Cl minus ion will be moving towards the anode, where it will undergo oxidation to form the chlorine gas. Okay, this H plus ion will be moving to the cathode, where it will undergo the reduction to convert to hydrogen gas. Right? And this Na plus ion and thus OH minus ion will be combining to form NaOH. This is what happening in the chloralkali process. Okay. And what is the main uses of the sodium hydroxide? Sodium hydroxide will be using this sodium hydroxide. Uses of sodium hydroxide, it's given in the reader. We will be mainly used for the paper industry and used as an alkali. Okay, and the hydrogen gas is mainly used as a fuel, right? It is used as a fuel and for carrying out the reactions, hydrogenation reactions and all. And chlorine we will be mainly used to disinfect water or for the production of bleaching powder. Okay, so the uses of each and every byproducts of chloralkali process, it is clearly mentioned in your reader. Please refer that one and study that one also. Okay, now that is the first question for 5 marks. Now we can move on to the OR question for 5 marks. That is, Reena, while doing certain reaction, observed that heating of substance X with vinegar-like smell with a suitable substance Y, which is used as an industrial solvent in presence of concentrated sulfuric acid on a water bath, gives a sweet-smelling liquid Z having the molecular formula C4H8O2. When heated with caustic soda, that is a... Okay, I forgot to mention one use of NaOH, that we are using NaOH for saponification process, right? You can mention that use also in the previous question. So when heated with caustic soda, Z gives back the sodium salt and the compound Y. Identify X, Y and Z and illustrate the changes with the help of a suitable chemical equations, right? So while I am reading the questions itself, you got what is X and what is Y, right? Okay. So here clearly given that X is a vinegar-like smell substance, right? So we can say from the given data, the vinegar-like smelling means X can be what? Acetic acid or ethanoic acid, right? Acetic acid or ethanoic acid, as it have vinegar-like smell. Right. Now, what is Y? Y is given, it is used as an industrial solvent. We are learning methanol, right? Methanol. Sorry, not methanol, it is ethanol. I am extremely sorry. Ethanol, right? That is we are using as CH3, CH2, OH. Ethanol, which we are using as industrial solvent. And when you treat it in presence of concentrated H2SO4 in a water bath, a sweet smelling liquid Z. So what will be that sweet smelling liquid when the ethanoic acid react with ethanol in presence of the dehydrating agent concentrated H2SO4? It is nothing but the ester, right? So the Z formed here is CH3, COO, CH2, CH3, or you can write CH3, COO, C2H5. Both are okay. That is ethyl ethanoate, which belongs to ester family, right? And it is given that it have a sweet smell, and as well as the formula is also mentioned. C4, we have 1, 2, 3, 4, C4, and 3 plus 2, 5 plus 3, 8 hydrogen, and 1, 2, 2 oxygen, right? So you have C4H8O2, which is given in the question, is matching with this formula, right? And as it is mentioned, it has a sweet smelling liquid, and definitely as ethanoic acid react with ethanol, we will be getting ethyl ethanoate. Okay, so we have to illustrate the changes, right, with the help of a suitable chemical equation. And when you are treating this Z with caustic soda, it gives back the sodium salt and the compound Y. We can write the both chemical equation for that changes. That is ethanol, CH3, CH2OH react with CH3, COOH in presence of concentrated H2SO4. What you will get? CH3, COO, CH2, CH3 plus water will be removed. Here, what is the role of this concentrated H2SO4? It acts as a dehydrating agent. It helps to remove the water. And what is happening in the reaction? This OH and this hydrogen from the acid is removed as water, and then CH3COO, this portion will be coming and binding here, CH2CH3. Okay, now we can just mention the name also, that is, this is ethanol. When it reacts with ethanoic acid, you are getting the ester, that is ethyl ethanoate, which is an ester. Okay, and when you carry out the hydrolysis of this ester in presence of NaOH, that is alkaline hydrolysis, you will be getting when you treat with the NaOH, alkaline hydrolysis, what happens here? The breaking will, here the breaking will occur, and you will get CH3COO Na plus this Na will come and bind here, OH will come and attack here, and you will get CH3CH2OH, that is the sodium salt of acetic acid, right? Sodium ethanoate plus ethanol will be getting. That is what mentioned in the question, that when heated with caustic soda, Z gives back sodium salt of X and the compound Y. We are getting the ethanol and the sodium salt of ethanoic acid. Okay, so it is clear, right? That is the 5-mark question. We have discussed both the questions and the OR questions. Okay, now we can move on to the last part, that is section E, which is a case-based question which carries 4 marks. Okay, so with this question we can wind up the session. Okay, so this is the case-based question, and the tabular column given below show the hints given for the by the quizmaster in a quiz, that is, we have a substance C which is used as preservative. Okay, and C has 2 carbon atoms, and C is obtained by A in the presence of alkaline potassium permanganate followed by acidification. What is the role of this potassium permanganate? Potassium permanganate KMnO4, which is acting as an oxidizing agent, right? And do you know any other oxidizing agent other than KMnO4? We have K2Cr2O7, potassium dichromate, which is also an oxidizing agent, right? And the misuse of A in the industries is prevented by adding methanol, benzene and pyridine to A. Now you got a hint. What will be? What can be that A? The industries, the misuse of A is prevented by adding methanol. That you have learned the denaturation of alcohol. The misuse of making the ethanol unfit for drinking by mixing it with methanol. That is what the denaturation, right? So here you got the hint. A can be. What can be that A? I'll write it in another slide. What can be that A? Now you got the hint that A can be ethanol, right? That is CH3, CH2OH. Now come back to the question. F is formed when heating A in presence of concentrated sulfuric acid, and F react with hydrogen gas in presence of nickel and palladium catalyst. Now we can find out easily A and C, F, etc. right? Because when you heat A in presence of concentrated sulfuric acid, you are getting F. So this is your A, right? And when you heat A, CH3, CH2OH, when you are heating it in presence of concentrated H2SO4, what happens? This H2SO4 removes the water. It acts as the dehydrating agent, and OH from this carbon and one hydrogen from the adjacent carbon is removed as water, and in between the carbon a double bond is forming, right? You will be getting CH2 double bond CH2 plus water, and the role of H2SO4 is dehydrating agent. So your A, ethanol, when you treat with concentrated H2SO4, you are getting ethene. That is your F, right? Now see, C is formed when you carry out the when you treat the A with the potassium permanganate. That is when you carry out the oxidation of alcohol. C is forming. What will happen when you do the oxidation of ethanol? CH3 CH2OH upon oxidation. That is you are treating it with the oxidizing agent KMnO4 and you are heating it. What will be the product? You will be getting the ethanoic acid, right? The acid, alcohol on oxidation give the acid containing the same number of carbon atom. So here you will be getting oxidation means you are adding oxygen. Okay, so you will be getting from ethanol, that is your A, when you treat with the concentrated KMnO4 oxidizing agent, you are getting ethanoic acid, that is your C, right? Now you find out C, A and F, and in the fifth one, F reacts with hydrogen gas in presence of nickel and palladium catalyst. So this is your F, right? That is ethene. So this ethene reacts with hydrogen in presence of nickel or palladium catalyst. What do you mean by catalyst? Which help to speed up the reaction, right? So what happens? It's an unsaturated compound. When you are adding hydrogen, addition reaction occur, right? Addition of hydrogen, and this double bond will change to single bond and hydrogen is added up. Already 2 hydrogen is there and 1 more hydrogen, that is CH3 single bond CH3. So what is the product? You are getting from ethene, you are getting ethane, right? From ethene, upon treating with hydrogen in presence of catalyst nickel and palladium, you are getting ethane. Okay, now you sorted out the data from this table. Now we can go on to the question. Give the IUPAC name of A and F. What is your A? A is ethanol. Its IUPAC name is ethanol itself, right? F is, what is F? It is ethene, right? Okay. And so you can write IUPAC name of A is ethanol, F is ethene. Illustrate with the help of chemical equation the changes taking place A to C and A to F. We have already mentioned here A to C, the chemical reaction, and C to, sorry, and A to F, that is also mentioned here, A to ethanol to ethene conversion with the chemical equation, right? Next, last question is write the chemical reaction which occur in step 2 and 5. In step 2, the oxidation reaction which we already mentioned, and the step 5, the addition of hydrogen. That is addition reaction or hydrogenation reaction is occurring there, right? And identify the compound formed in the step, in these steps, that is in the step 2 and step 5. If A is replaced with its next homologous series, we have A, ethanol. What is the next homologous member of ethanol? The next member is the one alcohol containing 3 carbon atom, right? So your next homologous series is propanol, right? So you want to find out the product, identify the product or the compound formed if in the step 2 and 5, if A is replaced with propanol. So in the step 2, if you are replacing A with the propanol, your product formed will be propanoic acid, because propanol, when you carry out the oxidation in presence of potassium permanganate, you will be getting what? Propanoic acid. And in the step 5, that is propanol, when you treat with concentrated sulfuric acid, you will be getting propene, right? And this propene, when you carry out the addition of hydrogen, that you will be getting what? Propene, on addition of hydrogen or hydrogenation, you will be getting propane, right? So you can write the name propanol and propane, alkane, because you are carrying out the addition of hydrogen or propene, you are doing the addition of hydrogen in presence of nickel or palladium or platinum catalyst, you will be getting propane. Okay. So with this question, we have completed the chemistry session of sample question paper 2023-24. Okay. So I hope all the questions that we discussed is clear for you. Okay. So for more practice sessions, please stay tuned with GoScore Learning. Thank you all.